So, okay guys, so we're doing this question here where sine A equals a half, and we're going to find two values of A from 0 to 360. So first thing I want everybody to do is, can you all sine inverse a half for me? When you sine inverse a half, what R value are you going to get? 30. Next thing, is sine positive or negative? A half is positive, isn't it? And its location is sine is positive, which means you're located in quadrant 1 and quadrant 2. So what's the answer for quadrant 1? 30 degrees. And what's the answer for quadrant 2? Yeah, done. X is 3.9 or 3.10 in your regular book. Okay? Now, you go back a step, and then you go, all right, I got these two answers. Happy days. Now we're going to go on to the actual projectiles question. And the projectiles question is as follows. A particle is fired from a point on horizontal plane with initial speed 28 meters per second and angle alpha to the plane. If the range is 40, find two possible angles. Okay, so it goes up, comes back down again, and what we claim in this distance here is 40. Okay, now it's shot up at 28, isn't it? At an angle alpha, yeah. So what does that mean about the adjacent sides? 28 cos alpha. The opposite sides? Anybody know? Yeah, 28 sin alpha. Okay. We're going to set up our four equations. What's phi x, guys? The velocity along the x-axis. Anybody tell me? 28 cos alpha. Along the y-axis? Minus gt. Sx. Anybody? Yeah, so 28t cos alpha, yeah? And sy, we're using s equals ut plus a half at squared. Yeah, so 28t sine alpha, yeah, you're right. You said minus 4.9, did you? So that's a half of gravity, isn't it? T squared, yeah, good job. All right. Now, here's what I'm thinking we're going to do. Two ways of doing this. I'm trying to think of just a better way of doing it. Yeah, I have an idea for this, all right? Sort of two ways of doing it. Depends what sort of battle you get locked into here, okay? So what we're going to do is we're going to find the time of flight. Is that right? How do you get the time of flight usually? You can put sy equal to 0, or what's the other way of doing it? Phi equal to 0 and double your answer. We'll do phi equal to 0 and double the answer. So we get 28 sine alpha equals gt, and our t value is 28 sine alpha over g. Now I have to double that, don't I, for the TOF? So what I'm saying TOF is 56 sine alpha over g. Now, we're now going to use this formula here. We see that blue formula? That blue formula, it equals 28t cos alpha equals 40 at the time of flight. Would you agree with that? So I can sub in the time of flight, can't I? That should work out. So it should be 28 times 28 sine alpha over g cos alpha equals 40. All right. Now, what's 28 times 28? 784 sine alpha cos alpha all over G. Now, there's a real, I told you about it the other day, but let's see if you remember it. 2 sine A cos A is what, guys? Anybody remember I wrote it down last class? Sine 2A. It's on page 13 of your maths tables, okay? So what I'm going to do is I'm going to half this. So I'm going to half that number. What do I get? 392, yeah? Multiplied by 2 sine alpha cos alpha. And what can I change that into? 392 sine 2x or sine 2 alpha, yeah? Over G. Now here's what I want everybody to do now. I want you to multiply G 40 by 9.8. And then I want you to divide it by 392. What'd you get? You got 1. Okay, no hassle whatsoever. Now, sine 2 alpha equals 1. Here's what we're going to do next. Sine inverse 1. So 2 alpha equals sine inverse 1. And what you get? And we get 90 degrees. Divided by 2. What you get? 45 degrees is your answer for that one. Okay. 45 degrees. Particle is fired from a point on a horizontal plane with initial speed 10 meters per second. Its greatest height reachable to plane is 2.5 meters. Find the sine of the angle of projection. Okay, so once again, what we're thinking is we're firing it up, okay? Da, 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 da. And back down again. And that there is our greatest height. You go with that? Okay. Next thing. It's 2.5. And then we're going to break up our component for 10, aren't we? So what's 10 again? Call it angle X. So what are we saying? 10 cos X and? Yeah. Okay. And now what's phi X then? Phi X, anybody? 10 cos X, yeah. Phi Y? 10 sine X minus GT. SX. Good man. SY. We all good? Okay. What's our plan of attack? We're after the greatest height, aren't we? So what's the recipe for greatest height? Vy equals 0, yeah, let's do Vy equals 0. So put that equal to 0 and bring the GT to the other side. So we just get GT equals 10 sine X. And then after that, guys, 10 sine X over G, yeah? And then what form did you want me to put it into? I want me to put it into SY. Okay. Let's put it into SY. So SY is 10 times 10 sine X over G times another sine X times a half G. I'm just going to square it out now, so I'm just going to square that out. 100, because 10 times 10 is 100. Sine X plus sine X. Sine squared. X all over. G squared, yeah? Then what happens next? They cancel, don't they? And I should get 100 sine squared X over G. Take away, what we thinking? 50. think I did something wrong here. Or maybe not. So I'm just going to go looking for a mistake. So it was asked why it was over 2g. Good question, and here's why. That g here cancels the square, not the g. And then on the bottom, you see the denominator 2 and the denominator of g, which multiply to give me 2g. All right. So here's what I'm going to do next. I'm going to turn this denominator into 2g. So what happens here? Doubled. And here? Doubled. When I multiplied the bottom by 2, I have to multiply the top by 2. So that's 200 over 2g. So what's my answer? 150 all over 2g, yeah? And we're told that the maximum height is? Okay. So you get 2.5 and multiply it by 2g. So what we're going to say is that sine squared x is 2.5 multiplied by 2 times 9.8. Then we're going to divide it by 150. So what you get for that? 0.32? 326? Square root that. What you get? 0.571. Sine inverse that. 34.81.